Well, hello there and welcome back. So it is the next day and I'm still with this monkey in the middle puzzle. I thought maybe very naively that I could get a solution yesterday in like an hour of time that I had. But no, apparently that time was taken entirely by trying to parse these pesky monkeys. But in the end, we did manage to do that. And so if I remember correctly, if I run this, we do have the different monkeys data. And we have this horrible function to parse a monkey. So today I don't want to keep wasting lots of time trying to improve this function. I'm sure there's a lot of things that could be improved here. And also I'm sure that the time it took me to parse this thing, it's mostly because I'm not very experienced with Rust, and I'm pretty sure that if I were more experienced, I would have probably gone for a better solution right away. But well, that's why I'm here trying to learn Rust during these Advent of Code challenges. I was also considering that maybe this kind of puzzles, they might be a good candidate for using an external library, like a regex library or something like that, to aid the parsing and make it easier. Because I'm pretty sure, like, if I would have done this in Ruby, for instance, which I'm a bit more fluent, and it has also like built-in regexes, this would have been a breeze in comparison. But again, I think most of it is my lack of experience. So let's leave this parse function as it is for now and assume that it's working correctly and try not to look at it very much. Let's add these changes and try to actually do the simulation that we wanted to do. So in this simulation, let's take a peek at the instructions again. We had to simulate, I think, 20 rounds of monkeys doing this inspection of the items and then throwing the items between each other, and count the two monkeys that have the most items inspected. So how are we going to do that? I guess we can start kind of top down here and say for round, I don't think I need the round iterator. But let's go 20 times, and this will be each round simulation. And what are we going to do in each round? Well, we are going to go over each monkey in turn and make the monkey inspect all the items that it has and pass those items to the other monkeys. So maybe we can use here a mutable iterator, maybe. I'm already thinking ahead in terms of having like multiple mutable borrows and not wanting to have that. Well, maybe let's try it. So for monkey in monkeys, and we're going to need a mutable iterator. I keep typing inter. So what does the mutable iterator give us? A mutable reference to a monkey. Perfect, that's what we want. And how do we make a monkey inspect its elements? Well, since we have already declared a structure for a monkey, I was thinking maybe it could be a good idea to delegate this logic to the monkey itself and do some sort of like object-oriented kind of code here. Since the monkeys are, a interesting data structure that has quite a few fields. So let's see. Let's say monkey inspect item, and well, the monkey could maybe not have an item to inspect. So I think what this should return should be an option, and if the monkey doesn't have an item to inspect, it would be none. And let's say no, not option. Let's say if it is sum, and what would this inspect item return? I guess it would inspect the item that it was returned, and maybe the index of the next monkey, like the index of the monkey to which this monkey is throwing that item to. So maybe that was a mouthful, but it makes sense in my head. So let's say item, we were calling these things receivers, I think. Yes, receiver monkey index. Let's be very explicit. And this wouldn't be a let's, this should be a while loop. So while we have something, some index to pass, or while we have an item inspected, and well, let's throw it to another monkey. So I think here is where we're going to find trouble with multiple mutable references, but let's try. So we have this receiver monkey index, and then we would have items, and we can push this item that was thrown to this monkey. Save, and of course we are going to have many problems, but here the language server kindly provides a suggestion to generate this method. So let's see what it does. Oh, okay, pretty okay. Inspect item is actually it shouldn't be just self. It should be mutable self. But let's leave it here and face that problem of mutability, because we are going to have to take out that item from the monkey, and this should return an option of what? Of this tuple. Maybe you can call these things somehow like a throw or something. That's, well, let's say the items where i30 use, and the index would be usize. Okay, and this doesn't like it because item in, no, here we still need the let, of course. That is good. That is good. And monkeys, yes, we cannot borrow this mutable again. So how are we going to sort of split this mutable reference? Maybe we don't need to do so. Yeah, we have a mutable reference to a monkey, and it does make sense, you know. Rust forbids to have multiple mutable references to the same thing, and here we are borrowing these monkeys mutably in order to extract this mutable monkey, and we cannot use it again, and we cannot even use it again with an immutable reference. This could create some aliasing problem, like if the monkey we have here is passing things to its own, well, here it wouldn't be a problem, but in the general case, you know, proving that is not easy. So Rust is very conservative in this and forbids us from doing that. So I guess we could change this loop to do a monkey index from 0 to monkey's length. Like, I'm pretty sure that there are probably other ways of doing this. But yeah, let's do it. Let's do it in some way that I know of. So for this, we would need to have the monkeys indexed by this index, monkey index. And we have an inspect item. And again, what is the problem here? We're still having double borrows. Changing this to, because this is not mutable. That was my bad. So it was immutable from the beginning. So let's actually see what was the problem before actually. Yes, we have this. Yeah, let's go back to this version and actually have a mutable array of monkeys. So what does it send now? Yes, okay, as I was saying, we have a first mutable borrow here. I don't know if we can like forget about that mutable borrow for a bit. No, because this is still an iterator. And we also can't well, there could be other ways of doing this. But the way I'm thinking of was what we did before, of having a monkey index and iterating over indices. So that would be it, monkeys, monkey index. And now, no problem, right? Yes, okay. I guess if we try to execute now, it's gonna panic with a to-do, not yet implemented. That will be here. All right, so now how do we do this monkey inspection thing? Oh, actually, this should be mutable. And I'm wondering, does this cause any problem here? No, okay. How are we going to do this items inspection? Well, I guess the first thing that we would need to do is to say self items first. Actually, can we pop from the beginning? Is there a shift method? I think in order to pop from the front of this vector, we would actually need to use not a vector, but a deq. I'm not sure how this thing is pronounced, but it's a collection that is like a vector. It supports everything that a vector supports, but it also allows like pushing from the back or from the front. I think internally it's probably a vector that holds an array of data, and it's a circular array. So if you pop from the beginning, it's just moving an index like from where it starts, or something like that. But this thing should have a pop front, and this conveniently returns an option because this could be empty. So we could say let some item be this thing, or else return none. Right? Yeah, I think so. I think that this could even be like this pattern could even be reduced as this. And now that we have an item, well, this item is actually like the worry level that we have about the item itself. But let's see. Then we have to do this operation on the worry level, I'm pretty sure. So monkey has the attributes. It inspects and throws all of the items, blah, blah, blah. Then, okay, so if I remember correctly, we have to do something like, well, this would be the new worry level. We will have the operation that we have already parsed, and it's this thing that I don't want to look at because it's kind of horrible, but this is a closure that actually I didn't. Last time I learned that if I call this closure this way, it doesn't like it because it thinks it's a method call. I'm wondering if there is a way of doing that. Call closure member. I have to do this horrible thing to tell the parser, hey, this is not a method call. Oh, look at that. That's yeah, that's a bit ugly to look at, but okay. This would give us the new worry level, and then we will have to divide this by 3 after the inspection is done. So new worry level divided by 3, and I guess they should have to be mutable to be able to do this. And then what else do we need to do? Well, we have to, oh sorry, it was the division. Yeah, when was this thing done explicitly? Exactly. Do we have an explanation for this? I don't remember if the inspection, like if the test was done before doing the division or not. Oh, it is in this explanation, I think. Divided by this, then goes by this. Current worry level is not divisible by is thrown to monkey 2. Okay, so I think now it's the time to do the divisibility test. So if this new worry level is divisible by this divisor, then well, here we are deciding which monkey to throw this to. So let's receiver be this self if true receiver, and if it's not divisible, well, actually to tell if it is divisible we have to do this, else self if false. Okay, and actually, is there something like divisible? I wouldn't be surprised if there is, but we can use the modulus operator here. And finally, we can return some new worry level and the receiver monkey index. So that should be, I think that should be it for one inspection. And actually, we care about counting the number of inspections. So in here, when we popped, actually, I'm not too sure if if I like this short circuiting thing here, because this is like an early return of none, and it's not as explicit as I would like to. So I'm going to be super explicit here and do an else, because I feel like this is like important control flow. Maybe that's question mark syntax I could use more for results, and maybe here in parse monkey I could use that to improve that code. But for this, I think this is really important part of the logic, so I would keep it as that. So here we have one return and the other return, so we can maybe increment a counter for this. So inspections count, or items, well, inspections is alright. Inspections count plus equals 1. And we need a member for that. So if it is a count, we could use whatever, usize, or, you know, let's use i32 for stuff that we don't know. We're probably needing this here. Inspections count, 0. Okay. And now for push, push back. Yeah. So the vec, this vec deck only has push front and push back, but it doesn't have a generic push. Very fine. So with this, we would have, I think, simulated all the inspections for a single monkey, and then this is a single round, and then this is the 20 rounds, I think. So let's actually print the number of inspections each monkey has done. In monkeys, iter, so println let's also take an index. So we could say monkey index did the inspections, and here pass the monkey inspections count. Let's run. And look at that, I think I recognize these numbers. These are the correct numbers, I think. 101, 95, 7, and 105, and that's right. Okay, so the simulation was much easier to do than the stupid parsing. Darn. So okay, now that we have this, we have the correct counts for of inspections. We need to grab the two most active monkeys and multiply those two numbers, I think. So how do we do that? Like, I'm sure we can do something like monkeys, iter map, and we can have for each monkey the inspections count, and get the maximum of that. But I want to have the two biggest numbers. So I'm pretty sure that I have already searched for this at some point. So get n max, gets n maximum items, most frequent, no. I'm pretty sure that I could do something manually for this, but I know of another way of doing this, which would be to collect these things into a vector. So let's call it let inspection counts be this, and this would be a vec something, epoch of what? 532, perfect. And sort these things, inspection counts, sorts. Yes. The sort, what does it return? It doesn't return anything, I think. So yeah, it needs to be mutable. And then once it is sorted, we have the two biggest ones in the end, I think. So we'll have, let's say, let's to most busy monkeys. I don't remember how it's called. Yeah, I really want to use the monkey business name for a variable. So the two most active monkeys. Yes, let's call it two most active monkeys. It's gonna be, oh, but we have the inspection count, not the, well, it doesn't matter, right? Because we need to multiply these two things. So let's call it actually monkey business. And I guess the correct name should be monkey business level, because what is the level of monkey business at after blah blah? Stuff slinging simian shenanigans. I love this, that phrase. So let's call this thing monkey business. That is exactly what we want. So this is going to be the inspection counts, and we're gonna get the topmost two. So how do we do that? I guess inspection counts length -2 till the end, and these two things we can iterate them and get the product. Isn't that the monkey business? Type annotation needed. This should be, I guess, an I32. Yes, thank you. And let's print the monkey business. Not like this. Formats. This would be monkey business. What do you complain about? Oh, I missed the closing brace. All right, and I think this is the correct number for the sample. That's very good. Let's copy then the actual input. And let's go. Is this the correct monkey business level for this puzzle? Submit. Yes. Oh, yes. So simulation, like the moral of the story is that simulating things is much easier than parsing sometimes. Like this is the code for inspect, and this is the code for running all the rounds. And they are, you know, it's pretty sensible code. I mean, sensible looking, and it's not too easy, too difficult to read. Whereas this parse monkey thing is this horrible mess. Okay, but we have to do part 2. So let's actually read part 2 before thinking about nuking that mess of a method. All right. Part 2. You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Oh no. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You need to find another way to keep your worry levels manageable. Yes, otherwise we would run out of bits to hold those numbers, I think. At this rate, you might be putting up with these monkeys for a very long time. Possibly 10,000 rounds. Oh, what is this? Some biblical story or something? With these new rules, you can still figure out the monkey. Are we going to need to simulate 10,000 rounds? Okay. With these new rules, you can still figure out the monkey business after 10,000 rounds using the same example above. Okay, after round 0, monkey inspected items 2 times. Yes, okay. So we're going to, yes, we need to, okay. I'm thinking ahead of myself, but after this amount of rounds, the 2 most active monkeys inspected items, well, 52,000 times. Multiplying this together, the level of monkey business is this pretty big number, 2 billion something. Worry levels are no longer divided by 3 after each item is inspected. You will need to find another way to keep your worry levels manageable. Starting again from the initial state in your puzzle input, what is the level of monkey business after 10,000 rounds? Okay, so this seems to have changed some of the rules. We don't need to, we're not going to be dividing these, and these numbers will go up pretty high. Okay, so let's think. I'm pretty sure if I don't do anything clever here, we are gonna get like an exponential runoff, because there was actually like an exponential thing here, like an old times old here. Whenever we get to that, we're going to get to very big numbers very fast. And that's not good if we have limited precision integers like i32. We could switch maybe to like u128. So because none of this is subtraction, so I think we don't need to have signed integers. But still, it feels like there's probably some clever thing to do, like, because then we are testing this in order to do the passes by some modular arithmetic. So maybe we don't need to keep those giant numbers. If we're going to then do a mod test, we can just, maybe you could just mod this, like do the operation, but then keep the mod of that item worry level. But that mod is fine for one monkey. But not for the others, because the other monkeys, each monkey has a different divisibility test. And actually, this divisibility test, look at that, they all seem to be prime numbers. Look at that. That tells us something, I think. We have like 8 prime numbers. If we multiply all those 8 prime numbers together, we're probably going to, like, we are going to get a number whose factorization is those 8 prime numbers, which will be big but not humongous, I guess. And then we can, whenever we do an inspection, we can do a mod by that number to avoid getting explosive results, I think. Yeah. Or another thing that we maybe could do, I'm not sure, is to have some memoization kind of trick. No, because the worry levels now won't go down, so it's not like we can have a log of what the different rounds were and, you know, do some like repetition from that. So okay, let's do try to do part 2 in some way. So level of monkey business after 10,000 rounds. let's call this thing monkey business part 1, because we are going to have a monkey business for part 2. And I really don't like when you rename things that the renames don't affect the format macros. But anyway, we hated this parsing logic. I think we are going to have the parsing logic again because yes, we need to reset the state of things. So let's do just that. And monkey business part 2, we are going to print that in here. Okay, so how are we going to do this now? We have the same monkeys, but now we're going to do 10,000 of rounds. Great. And we're not just going to inspect items. Actually, this inspect, I think we could call it inspect and throw item to give a hint that this thing is like mutating the item, the items array. So, and let's call this thing actually a throw and extract these things here. You know, have slightly more readable code. And do the same here. Call this thing a throw. Yes. Okay. So this should run, I guess, maybe. No. Attempt to multiply with an overflow. Look at that. And well, the backtrace is not useful here. We could enable, I guess, Rust backtrace 1. Append of code. Where is the multiplication? No, I guess. Oh, it's this product. Okay, that's something that we can probably increase the size. Let's use 64 bits and see. Well, no. Let's do inspection count as I64. Run again. Okay, so now we have a number. We could have a number. And this is for the actual input. Let's go to the sample input. Run again. And we again got an overflow. Where is this now? Okay, now the overflow is when we are doing the operation. Yes, okay. And does it point to? Yes, it's when we are doing old times old. Okay. So these things are exploding a lot. And they will keep exploding, I think. Even if we, like, let's change I32s to be, like, let's undo what we just did and keep the I32s as we were doing before. So this I32, this thing, all of these things, why not? Yes, these two, all of this. Sure. Yes, let's go. Yes, all of this. Let's change them to, well, 64 bits unsigned. And let's run. We still get an error. Attempt to multiply with overflow. And yes, it is in this line. So even with 64-bit numbers, we are screwed. So I'm thinking, like, it does make sense to use unsigned integers. That's not a problem. What is a problem is the exponential nature of this thing. And we weren't even dividing. Like, no, we didn't even change the logic of this inspect and throw. So that's weird. It seems like it already explodes even without the division by 3, but it will explode even more. Like, let's make sure that actually this code is not causing problems. Like, the first part should still be giving, yes, it's still giving the correct answer there. Okay. But now let's do an inspect and throw item. Without, well, let's call it part 2, because it's going to be the same thing, but for part 2. The logic will be basically the same, but we are not going to divide by 3 here. And here it's going to be part 2. Okay. New array level doesn't need to be mutable. Fine. And this thing will more quickly, I think, explode. The explosion this time is coming from all times the right hand side, so yeah, it's going to be exploding no matter what. But I think we can use that observation about all of these things being prime numbers. Like, if these things weren't prime numbers, I think it wouldn't be a problem to get the multiplication of all of those and then doing the modular arithmetic on that. But being prime, I think being prime numbers is kind of a hint on that. So we can also get this number. Let's say, let's div, how is this thing called again? Div test divisor. So let's call it divisor's product. And we're gonna get all the monkeys and map them into this div test divisor, and then get the product of this. I think you like to have an explicit type. Let's do U64, and let's pass this thing into this inspect and throw. And of course, it doesn't suggest what to do. So let's go here. Div source. How do you call this thing? Mod. Well, mod is a keyword. Modulus. Or I don't know what would be a good name for this, so I'm just gonna call it mod divisor and test if this works. So we have the new worry level, which would have updated by this, but let's keep it at modulus, modulus this thing. So the idea is this won't change the result of this if, because this modulus divisor is a multiple of this divisor. Like, it's multiplying this by other things. So doing things won't change the result of this, but it will keep this thing clamped, like limited to a given value of this. It won't be higher than this mod divisor. And actually we can print that thing out. Where is it? Here. Let's print ln this divisor's product. Let's run. Okay. yeah, this divisor product is just 96,000, so it's a much smaller number. And this does look like the number that we had in the sample, 2 billion ends in 58. Let's see. Yes, it is this number. Nice. So we can do the simulation now with our 8 monkeys. So let's redo here, save and rerun. And look at that, it didn't take, I thought it might take some time, but would it be this number? So it is 13 billion something. Submit. I should say 13,000 million, but yay, look at that. That is a gold star. Okay, and we didn't need to go for arbitrary precision integers, which I guess would have been the default mode in languages that have arbitrary precision integers. So that was very good. Very nice. Should we do something more with this? So I guess this, well, let's actually add all of this. And we are getting the correct answer, right? So yes. Let's do something that I usually don't do, which is to commit right away and then clean things up. So yes, let's git commit this. This is the 11 solution. And let's now think of how to make this a bit better. So we're gonna have part 1, part 2 here, and we are repeating quite a bit of code. There is something that I feel like we can do here. So the thing about the divisors product is something that we can do for both parts. So we can put this thing in here. And we can do this inspect and throw item like the difference between these two is that one is receiving this mod divisor and the other one isn't, but we can keep this in the 2 versions. Like we can upgrade this to also do the mod division, like no harm done in that. We are only simulating 20 rounds compared to 10,000, so it's not like adding this to those 20 will make any difference in performance or anything like that. And the other thing that we are not doing in this version is dividing by 3. So to do that, maybe we can just pass a boolean to tell, hey, diminish worry level or not. I don't remember how this was called in the pros here. Relief. The relief that the monkey inspection didn't damage. Yes, so relief enabled, let's say it's a boolean or enable relief. So I don't know if enable is like relief as after inspection. Yes. So if we have relief after inspection, then we are gonna do this. Otherwise, we're not going to do that. And then we keep the same thing, and we don't need to have 2 separate methods for this. Yes, this would be this, and relief after inspection in this case will be false, and relief after like here we also have to pass the source product, and relief after inspection would be true. Okay, and now I think we can have part 1 and part 2 very like extract this thing into a function that just runs the simulation, the rounds. So okay, let's extract into run fn run monkey in the middle rounds, and we're gonna have, well, we could have the monkeys and do the parsing only once, I guess. So should we do that? Yes, we have already parsed, and yeah, let's pass in the monkeys, I guess. We could have a mutable reference to a clone or something like that. Yeah, let me think. Well, let's first just copy the code, and then we can think. We're gonna have these basically, and we are gonna return the monkey business, and it won't need to be called part 1. So we have that monkey business, and we can receive the vector of monkeys, I guess. Yes, we can do the parsing once and pass the vector of monkeys. But we would need to have the monkeys be copyable, I think. And I'm already thinking that those closures are probably not going to be. So let's actually try that out before finishing this. Let's see if we can derive copy here. So derive copy. Okay, so this field does not implement copy. Yes, there are some things that cannot be copied. So a vector cannot be. Oh, I guess we can derive clone. That's what I think I want. But even the operation cannot be cloned, right? Let's see. The treat clone is not implemented for this thing. Yes, okay. Because it is a closure. So that's fine. I just want to get rid of like the duplication here. Not get rid of the duplication, but you know, it's mostly the same thing. These two things. So we can have a function that does this for us. So well, it seems like we can't be cloning this data structure for now unless we do something else with the operation. So let's keep it at that, and let's just pass in the inputs then. Input's gonna be a string slice, and we are going to also have this parameter, which was relief after inspection. Relief after inspection is going to be a bool, and we are gonna pass this thing in here. Yes, and we're gonna return the monkey business at the function return type. Yes, indeed. And now we can probably, if I didn't make any stupid mistakes, get rid of all of this, and we're gonna have the two answers right away. So run monkey in the middle rounds. We are gonna run with this. And the other thing that we need to parameterize, of course, is the number of rounds. So here is the rounds count. Let's make it a usize. And relief after inspection is going to be true in the first one, but false in the second one. And it's going to be 10,000 rounds. Okay, and we are going to use this in here. And how about now? Yes, it seems like it's still the same results as before, I think. Yeah, very good. So we have sort of abstracted this part 1 and part 2 into, or parameterized these two things with the round number of rounds, and if there is relief after the monkey's inspections or not. All right, so what else? In this code we have the monkeys we are parsing. We have yes, yeah, the visitors product is fine, I guess. Kind of a trick. Let's take note of this trick. Keep track of the product of all divisibility tests visitors in order to clamp. Well, clamp is not so that each time the worry level for an item is increased, we can mod that number with this and keep it from ballooning out of control. And how is ballooning written? Something like this, ballooning. Look at that, using fancy English. So so we have the rounds simulation, then we have this inspections count, which is not I would really like to have something in the iterators to say, hey, give me the maximum 2 of this. But I cannot think of some easy way of doing that. So we do it the cheesy way then, sorting and getting the last 2. That is fine. And okay, I'm fine with this code. I am fine with the monkey's data structure definition, I think, maybe except for this dynamic dispatch thingy, but other than that is fine. And then we have, well, the inspect and throw items for a monkey, which is fine, I guess. Inspections, counts, new worry level, yeah, grades. divide by 3 if there is relief, calculate the receiver, everything is fine. And now the parsing logic. Okay, so I guess we can commit this change that we have just done as a separate thing. So struct or generalize part 1 and part 2 into a function that simulates an monkey in the middle rounds. Okay. So what do we do about this parsing? Darn, this is hard to look at. Well, there is a couple of things that we could do to improve this, I think. So first, one of the things, it may be a bit okay, the most obvious thing here is what we were trying to do in the last video, and I couldn't, which is to parse these numbers. Actually, here we are parsing numbers, and the items are also numbers. So that's pretty easy, I think. Let's take a look at the, yes, throw to monkey 6, yes. So we can do something like, let's think. This would be parse a list of numbers, I think. Function parse numbers. We're gonna have just a string, and not, oh, okay, veq, okay. Well, let's keep the parsing of the items in length here. That is not too bad. Then comes the operation, which is another mess, and then we have this. These things are parsing a number from, like, at the end of each, divisible by blah blah by. Okay, so we can do something like call this thing again, extract it into function, call it parse last word as number, and we're gonna have a string again, and this and this. Okay, and here we're gonna parse, this was line 4, and it will return, yes, it can return a usize, I guess, no problem with that. And yeah, let's do the same here. Parse last, parse last word as number, and lines data two. Okay, here we would need a explicit type conversion, not this U64, that's fine. And okay, don't need to say last word as, let's parse last number. Yeah, maybe we can leverage the result thing. and say, hey, this is going to be a results, and we can do something like this. Let's allow the compiler to tell us what this should be. What the hell? Okay, or to write an error with results. Yeah, okay, and we would have to propagate this thing up, I guess. So, would this make things better, I wonder? Can it be used for results? Okay, so what is the result of parse? Okay, so last returns an option. Well, maybe you can say an option like this. And parse yes, okay. There's a result infallible. Okay. Can we say ok then? Okay, so we are parsing this, and I guess we could say something like we're gonna parse, but we want to fail. We don't want to. That's the thing. Like, we would like to fail. And it would be better to fail with an error and propagate those things. So let's forget the idea of returning result here, although it's made a nice one-liner there. But let's keep it, panicking as it is right now, and not think about that failure mode. So this is already an improvement. At least we are testing and doing this here. Let's add these improvements. Another thing that I was thinking was maybe instead of doing these lines data, and the name of this is pretty ugly, we could have probably just data. And one thing that I don't like is that we're doing like 0, 1, 2, 3, 4, and so on. So maybe we can do something like collect this into a hash map of something. So hash map, well, what are we going to do in this hash map? Well, we can do the same splitting here, but keep the two things. So this would be a tuple, and let's see if the inference goes fine. Yes, this would be a hash map of, where is the type of this? No, data. Yes, a string to string. That's very good. And now we can say things like, but I think we probably need to clear up the trailing white space here. Not trailing, starting white space. But we could access this and say, instead of 0, saying starting items, and have better keys for this sort of thing. Yes, but let's actually print line this data and see what shape it has. Actually, let's try out the pretty printing I learned the other day. Well, of course, the other accesses are not working now, so this would be operation, data operation. Good. Here we're also dealing with data operation. This is test. And what else we have? If true and if false. So, you know, instead of having just indices there, it's a bit more readable, I guess. Okay, let's run. And yes, it has this starting white space. So can we, before saying split once, let's say trim. Oh, this is what I wanted the other way. It's not strip, it's trim. Trim starts. So trim start does leaving white space removed. That's very good. Let's have a stupid message here, invalid data line. Yes, I just want to have a one-liner for this. Let's run now. And we have the results. Very nice. It's okay. We now have the data here, collect into a hash map. This is not that horrible now. I guess we can even remove these explicit types here. Yes. And yes, now I'm a bit happier about this parsing code, I guess. The last bit remaining is the this amazing operation, dynamically dispatched closure. So, can we do something better about this? I guess yes, the answer should be yes. So we have, oh, there is another thing that I was actually thinking of, that, you know, this, since we have defined the behavior of this program here in Monkey, inspect and throw item, we may also define this parse instead of calling it parse monkey. You know, let's be good object-oriented people and have it as a function on the monkey itself and call it parse. Right, and then we can have this map to monkey parse. Look at that, modularization, amazing. Oh, but this also needs a whole new level of indentation and things like that, so maybe I'm not too happy about this now. I don't want to have more indented code, and yeah, let's not fiddle around too much with this. So yeah, let's keep it as it was. No, not here, in here. Okay. Forget about what I was saying. How could we improve this operation parsing? Well, one thing that we could do is, yes, here we are boxing this. That is fine. We could also do something like generalize this to So how are we doing this? So, I'm trying to think of what would be the best idea for this. Let's give, because I'm thinking of, this is now a closure. We could do this parsing here instead of special casing for plus or times operations. We could capture this here into like an operation symbol or operator, I guess, and have the if inside the closure that we are returning, like the conditional for that, like that could work. Same thing for old and right hand side, but would that work? Well, let's give it a try first. So here we could say operation if op is plus or sorry, some Python sneaking in there, or operation is this, then we can have, here's the closure, so we can move the conditional in here, right? And say something like if operation is plus, well then O plus right hand side, else have O times right hand side. And remove this, and doesn't look any much better, but we got rid of this case basically. And this is yet another case, let's move it up here, where we are adding, well, the right hand side could be called old. We could actually move that into the closure too. So something like this, and say something of the sort. Let me think. Yes, we could do something like let right hand side number be, well, an option of a number, and then if right hand side is old, well, no, if it is well, if it is old, then it will be none, else it will be sum and the parsing. Let's sketch this out and see if it makes any sense. And then inside of here we could say something like the right hand side, like the actual right hand side is gonna be, it's gonna depend again, like we are doing sort of this same operation, right? You actually move it, but I don't want to move the parsing of the number into here. So yeah, all of this doesn't seem like a very good idea. Even these, what we have done in here. Oh, this is now, wait, what don't you like about this? Trim starts. lifetime may not live long enough. What? You were working before, I think, weren't you? Wait, let's forget about what we were doing with the operation parsing. And okay, for some reason changing here the operation was messing with this. Oh yes, because I think we were starting to capture, yeah, the value of the old string, and we probably would have needed to move it or to put it on an owned string. Okay, so let's actually commit this change that we have now. Improve parsing slightly. Actually, let's check what we are committing. Yeah. So we changed mostly this to put it in a hash map and refer to things with better keys than just 1, 2, 3. And it's a bit less code, but I think it is also like a bit better to read. So that's fine. Let's commit this and let's try an experiment. Let's try to see if it would be better to have this operation instead of be a closure, like a boxed closure that we are dispatching dynamically. If it would be better to have like a reified operation, like a struct that represents this operation and has the operation data, and then when we call the operation, we calculate, like you do the calculations in there instead of having like a closure that does it. I think in terms of performance, even if this is using dynamic dispatch, I think it would be better, but maybe the other way things would be more explicit, maybe. So let's give it a try. Let's say that operation is no longer this boxed closure. Let's call this thing an operation. And this operation, what will it be? Well, we could have, we're gonna have multiplication or addition, and maybe this could be an enum then. But actually, we're going to have the right hand side on both cases, and maybe we can even have. Let's go for a full modeling of this thing. Operand, and the right hand side that would also be an operand with that, and an operator, which will be an, you guess it, operator. So what are these things? Well, an operand, actually this will be an enum. An operand will either be old, representing the old value, or a number, representing a number. So that's it. And we're also going to have an enum for operator, should be add or mod. Okay. And that's it for it. And now we have to parse these things. And we can have something more generic this time, I guess. Operation. Let's see. We can probably infer this type. And we can have new equals, well, let's call this thing now left hand side. Right hand side. So if we have this, or same thing but with multiplication, we're gonna do, or actually this, What are we doing here? Yeah, let's capture the same logic that we were doing before. Again, I keep putting the multiplication first, or operation equals this. We're gonna have an operation then. We can maybe call this thing parse operation. We're gonna have left hand side, right hand side, and operator, I guess. We can get rid of all of other cases. Actually, I'm starting to like the idea of putting the parsing functions inside these structs implementations. So operation parse, let's generate this function. Yes, it should return an operation. Very nice. And yeah, how are we going to do this? Well, we could keep delegating, I guess. This will be an operation where the left hand side will be operand parse left hand side, and let's do everything via delegation now. Operand parse right hand side, an operator part. Let's be super consistent. OP-less operator. Okay. Now this parse for the operand should be pretty easy. So if it's not going to call it right hand side, let's call it just S. If it is old, then old. Operand old. Otherwise, we're gonna parse this number. Let's a number. Let's parse U64 and expect. Let's say. I'm not sure if the messages and expectations should be like this or something like should be a valid number or something like that, but okay. Anyways, operand num with this number. Okay. And finally, the operator parse. So we did a bunch of delegation for this. Let's see. So here we can match, I guess, match the operator and say if it's plus, then we are gonna simply operator add, and if it is a multiplication, then we are going to the operator modes, and otherwise we're gonna say unreachable, invalid operator. Okay, very good. So we have the parsing again, but now we are parsing into a data structure, which should make more sense, I guess. And we delegate a bunch of stuff. Very nice. Now that we have done this delegation, I actually feel a bit tempted to move this thing into the monkey struct again. So operand, operation, blah, 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 monkey. Here's the implementation for monkey. We can call this thing parse. We can call this thing monkey parse. Yes. And now, of course, the operation is not callable. can we run this? I don't know if Rust allows structs to implement the call operator. Let's see. Override call operator for struct. Okay, seems like it might. So this is the way you do it. Let's see if there is then std ops call. Okay, so there is an add, let's say trait call is there, eval, no. Okay, maybe we don't need anything like that. We can simply have a good old method for that. So I guess it would be nice to have this thing on the operation itself. So you could have a function called simply call. We're going to call this operation with the old value. So yes, old simply, and it's going to be this and return this. Or we could maybe call it operation eval. That's call is fine. And what do we need here? Well, I guess we can use delegation again. We can have the left hand side be the self left hand side. Let's go value and pass this old value, and we're going to do the same thing with the right hand side. So this needs to take a self-reference. Very good. We can generate this method, which should be a pretty simple one. We just have to do match on self, and if it is old, we will return this old, and if it is a num of something, we are going to return that. Well, operand yes, and yes, we can dereference you, that's fine. And now that we have those two, we can get the self operator and call with left hand side and right hand side. And look at that kind of object-oriented delegation. That's pretty fancy. Match self again, and if this is an operator add, then of course left hand side plus right hand side, and if it is a multiplication, we're gonna do the same thing. All right, so now we have operation and we can call this thing, and I see no red spots. Well, we do have a, I don't remember if this was the correct results. 13 billion and 2223 blah blah blah. Let's see. The possible answer was actually it was not that. So I screwed up somewhere. That's a bummer. So I was in a bit of a rush to implement this. What are you complaining about here? Unreachable pattern. What? I think I got something confused there. Oh, okay. And now I got a different answer. I should have paid attention to 248, and it is 248. Okay. So, okay, we did quite a bit more code for this. I guess one thing that we can do is to try to keep the structures and all bunch up together and the implementations separated, so we can see the shape of things and then we can see the implementation of things. And we can put the monkey I have better selection. We can use this. We can put the implementations after the struct definitions. Yes. And it is more code definitely than what we were doing before with a closure. But I sort of like this kind of modeling, because now, like, if I had to debug it, like before, we tried to do like derive the debug trait for this, and it was a mess because the closures didn't implement that. And now all of this is just plain data, no dynamic thing or functions or anything here, and then we are dealing with that data. And I also quite like the pattern of delegation that we achieved here, like parsing of the monkey. Well, it's still doing some stuff, quite a bit, but then it's delegating this parse to operation, and operation in turn delegates its parsing to operand and operator, and it's pretty neat. Kind of typical object-oriented code where no single function does lots of things and everything is about kind of delegation. But yeah, for this kind of thing where you're like modeling an actual thing in the world, I think it's kind of nice to have these tools. So let's do a side-by-side comparison, and it's probably going to be a lot more code. Indeed, 178 versus 122, but I don't know, maybe it is a bit better. I mean, this wasn't too bad either. Now I'm rethinking myself here. It was also nice to learn about having dynamic boxing. So maybe I could have this more object-oriented thing as a second version, because it's a lot more code. But yeah, also I didn't really like the special casing of this thing. Like this, it's a bit ugly, I think. Yes, I would just go with a new version. So let's commit this. So what are we doing now? Refi. Look at that word. Operation. I know words, but I don't know how to type into its own data type. Instead of having a dynamically dispatched closure, define an operation struct class operand and operator to model an operation with plain old data. Yes. Okay. Yeah, I'm pretty fine with this. And although it's a bunch of code for this puzzle, I'm pretty happy with the solution. After all the mess that was parsing this, I feel like the end solution is pretty good. So I'm gonna leave it at that. And well, I have to go for some Christmas celebrations. So Merry Christmas to you if you are watching this. And if you have been, thank you very much for watching. And of course, if you have any comments to do about my Rust skills and stupid things that I made during the video, please don't hesitate to leave those below. I would be very glad to receive some constructive criticism. So that's it for it today, and see you next time. Bye bye.